The morning sun catches on something sharp, a spine of living wood that juts from the trunk like a medieval pike. 10 inches of hardened cellulose, tapering to a needle point that could puncture leather. The honey locust thorns cluster in savage bouquets along its branches, each one engineered to inflict maximum damage. A sparrow lands nearby, weighs nothing. A deer brushes past, steps delicately around the fallen thorns. These modern visitors navigate the tree's defenses with ease. They're too small, too light, too careful to trigger such extreme botanical violence. The disproportion screams of missing context, like finding a fortress cannon aimed at an empty field. The thorns themselves tell a darker story. Their density, their placement along the trunk at heights reaching 20 feet, their tendency to grow in clusters rather than singles, all speak of attackers that stood tall enough to strip bark from treetops. Whatever creature these weapons evolved to repel possessed both tremendous height and an appetite worth defending against. The rabbit's nose twitches against the warty surface of the Osage Orange, its tiny paws struggling with the 5-pound fruit. Inside this grotesque green sphere, chemical factories churn out pomiferin and osagein, compounds so toxic that 2 tablespoons of concentrated extract would stop the rabbit's heart within minutes. The fruit rolls away, too heavy for the creature to manipulate. Black walnut trees leak dew-glown into the soil, creating dead zones where tomatoes wither and apple trees suffocate. A single Kentucky coffee tree pod contains enough cytosine to kill a full-grown cow. The black locust manufactures robin in concentrations that dissolve red blood cells on contact. These poisons don't merely repel, they annihilate with pharmaceutical precision. Yet the honey locust expends tremendous energy growing thorns longer than a grizzly bear's claws. The Osage Orange invests months developing fruits no living creature can swallow whole. Such extreme defenses drain resources that could fuel growth or reproduction. Evolution rarely tolerates such waste, unless the original threat demanded nothing less than total biological warfare. The rabbit's delicate skeleton would have crunched like kindling beneath the feet of creatures that ruled these same lands 10,000 years ago. Ice sheets stretched from horizon to horizon, grinding bedrock into powder, sculpting valleys where glacial winds howled at -40 degrees. This was the Pleistocene epoch, when winter lasted centuries and survival demanded size beyond modern comprehension. A mastodon emerges from the morning fog, each footfall sending tremors through permafrost. 16,000 pounds of muscle and bone, tusks curved like scimitars, trunk powerful enough to uproot full-grown trees. Its molars, the size of bread loaves, grind endlessly against vegetation that modern elephants couldn't digest. Bark, branches, entire saplings consumed in quantities that would strip forests bare. Through the undergrowth, claws rake against oak bark, each talon 8 inches long, attached to a ground sloth tall as a giraffe. Megatherium americanum rears on hind legs, 20 feet of prehistoric fury, using those scythe-like weapons to strip leaves from canopies no other herbivore could reach. Its leathery hide, thick as rhinoceros armor, deflects thorns that would puncture modern flesh like paper. The thorns had drawn blood before, but nothing like this. A massive shadow fell across the honey locust as Megatherium americanum rose on its hind legs, 20 feet of muscle and bone, reaching for the canopy. Its claws, each the length of a human forearm, raked down the trunk, shredding bark in ribbons, while the tree's 4-inch thorns snapped like twigs against hide thick as armor plating. The ground sloth's feeding technique was devastation incarnate. It would hook branches with those terrible claws, bending entire limbs until they cracked, stripping leaves and bark with a tongue rough as industrial sandpaper. Where modern herbivores nibbled, Megatherium demolished. The honey locust's response came measured in evolutionary time. Its thorns lengthened, hardened, their tips developing a density approaching bone. Fossilized honey locust thorns from the late Pleistocene tell the tale of this arms race. Some specimens measure 10 inches, their bases swollen into woody knobs capable of puncturing 2 inches deep. The tree had evolved a phalanx of medieval pikes, angled precisely to deflect a ground sloth's downward swipe. Each thorn represented 1,000 generations of trees that survived where others were stripped bare, devoured, destroyed. The honey locust's thorns could pierce hide, but the Osage Orange deployed a different weapon entirely. Its fruit hung from gnarled branches like grotesque green brains, each one weighing up to 2 pounds, their wrinkled surface oozing a sticky latex that burned the tongue. Inside this bizarre sphere, compounds named osaginine and pomiferin concentrated in lethal doses. A white-tailed deer approaching such fruit today would foam at the mouth within minutes, its nervous system seizing. But 12,000 years ago, a mastodon's trunk would wrap around these toxic orbs without hesitation. The beast's molars, each the size of a brick, ground the poisonous flesh, while its 40-foot intestinal tract neutralized toxins that would kill a horse. The mastodon's liver alone weighed 60 pounds, a biological refinery processing poisons at industrial scale. Where modern mammals possessed delicate digestive systems, these titans harbored bacterial colonies capable of breaking down chemical compounds that melted lesser tissue. The Osage Orange had evolved its deadliest toxins for an adversary whose very metabolism operated on a prehistoric scale. The mastodon's massive molars ground down another mouthful of Osage Orange, its digestive acids neutralizing toxins that would paralyze a modern elephant. But the tree learned. Each wound inflicted by megafauna teeth triggered a cascade of chemical responses deep within the cambium layer, synthesizing compounds more lethal than the season before. Laboratory analysis reveals this escalation preserved in fossil wood. Juglone concentrations in ancient walnut specimens triple those of their modern descendants. The honey locust didn't merely grow longer thorns, it laced them with alkaloids that induced hemorrhaging. Plants developed time-release poisons, toxins that activated only after digestion began, circumventing even the ground sloth's formidable gut chemistry. 10 million years of coevolution compressed into the Pleistocene's final chapters. A ground sloth approaching a black locust now faced robin levels that could rupture blood vessels through its 2-inch thick hide. The botanical world had transformed into a minefield of molecular weapons, each species racing to out-poison the voracious giants that ruled their world. The honey locust's steel-hard thorns evolved over millennia to pierce Megatherium hide, now jutted uselessly into empty air. Across the northern hemisphere, temperatures plummeted 8 degrees in mere decades. Glacial meltwater flooded into oceans, drowning ancient migration routes. The mastodons' bellowing ceased first, their massive hearts unable to pump enough blood through bodies designed for a warmer world. Starvation struck the giant ground sloths as their preferred plants retreated southward faster than the lumbering beasts could follow. Carcasses piled in valleys, a 3-ton sloth here, a mammoth family there, their flesh freezing before scavengers could strip the bones. The Osage Orange trees continued producing their toxic fruits, but no creature arrived to consume them. They rotted where they fell, their chemical weapons dissolving into soil. Within 500 years, the thunderous footfalls that had shaped botanical evolution for millions of years fell silent. The trees stood unchanged, their thorns still razor-sharp, their poisons still lethal, waiting for enemies that would never return. In the new, quiet world, smaller creatures, Deer, rabbits, squirrels gave the armed fortresses wide berth, instinctively avoiding defences calibrated for titans. The last mammoth collapsed 10,000 years ago, its tusks scraping frozen earth, but the black walnut trees never received word of the armistice. Their roots still pump juglone through cambium layers, manufacturing a neurotoxin potent enough to paralyze a ground sloth's massive digestive tract. Every spring, these chemical factories resume production, flooding their tissues with compounds calibrated for adversaries that outweighed modern elephants. Black locust trees bleed robin from wounded bark, a glycoside that ruptures red blood cells on contact. The honey locust secretes alkaloids through its thorns, while Osage orange concentrates isoflavones in concentrations that would have merely irritated a mastodon's iron stomach. These poisons persist at industrial strength, their molecular structure unchanged since the Pleistocene, waiting for tongues that could strip entire canopies in minutes. A botanist's spectrometer reveals the truth. Walnut leaves contain 50 times more juglone than necessary to deter modern herbivores. The compounds pool in soil beneath these trees, creating dead zones where nothing grows, chemical minefields designed for creatures whose footprints measured 3 feet across. The trees' vascular systems pulse with this ancient venom, their phloem streams carrying orders for a war that ended before the first pyramid was built. The same compounds that once deterred 8-ton ground sloths now course through suburban pastures, their molecular structure unchanged after 10,000 years. A Kentucky thoroughbred grazes beneath a black locust tree, its velvet muzzle brushing against fallen leaves that contain robin, a toxalbumin so potent that 3 grams could kill the animal in minutes. The horse's pupils dilate first, then tremors ripple through its flanks as the poison attacks its red blood cells, causing them to clump and rupture. Within an hour, the animal collapses, its muscles locked in violent spasms while foam tinged pink with blood bubbles from its nostrils, killed by a defense mechanism calibrated for mastodons. Veterinarians across America document hundreds of such deaths annually. Cattle poisoned by honey locust pods, children hospitalized after chewing yew berries, landscapers developing severe dermatitis from Osage orange sap. Each incident represents a biological miscalculation, plants still manufacturing weapons for a war that ended when the last mammoth fell silent in the frozen north. The morning mist clings to a suburban lawn where a honey locust towers, its trunk bristling with thorns that jut out like medieval pikes. A child's bicycle leans against the bark, the rubber tire mere inches from a spike that evolved to pierce hide 4 inches thick. The impenetrable armor of creatures that haven't walked this earth for 10,000 years. These botanical fortresses persist across North America, their chemical arsenals still primed. The black walnut secretes juglone through its roots, poisoning the soil in a 30-foot radius. Osage orange fruits rot where they fall, their toxic latex oozing into grass where no mastodon will ever come to feast, while honey locusts produce alkaloids that once deterred tongues the size of shovels. Each spring, these ghost warriors bloom and fruit as if the war never ended. In pastures from Texas to Ontario, veterinarians extract black locust pods from the stomachs of dying cattle. The trees cannot know their enemies vanished. They simply continue their ancient vigil, thorns sharp, poisons ready, waiting for the thunder of footsteps that will never come again.